First of all, thank you for coming. For us, this is really an experiment. So, yeah, thank you. My name is Stepan. I work for a company called SpeakApp. We make a voice messenger, and we have another product coming soon. Today I'm going to talk about drawing inspiration from languages, nature, and people. Give me a second to show my notes. Okay. So let's get started. Before we begin, I want to kind of warn you that the talk is going to be a little bit abstract, and you might not learn something concrete from it, but what I hope to do is to share some ideas and to inspire you. So yeah, let's get started. So I want to start my talk with a quote by Ludwig Wittgenstein. The limits of my language mean the limits of my world. So what does it mean? I believe that in order to think beyond what we used to think, to solve problems we've never been able to solve, to understand concepts we've never been able to understand, and to just basically grow and to evolve, we have to reach to other languages, cultures, nature, people, and even different media. So, surprisingly, the first example I want to give is about Russian language. So, assume we have a simple English sentence that says, our cat gave birth to 4 kittens, and translated to Russian, наша кошка родила 4 котят. So, the interesting part about Russian is that sentence structure is encoded into word endings, which allows us to freely rearrange words inside the sentence. And we can change it to something like that. 4 котят родила наша кошка. Котят 4 родила кошка наша. So, those sentences might sound a little bit weird and in Master Yoda style, but they're still correct sentences. And if you want, I mean, we've managed to rearrange the word, and we didn't have to change words, actual words. If you want to do the same in English, you will have to change the words, obviously. So yeah, obviously it adds a lot of complexity to the language. If Russian wasn't my first language, I will never been able to learn it. I'm pretty sure. But this complexity adds a lot of freedom. This is what makes Russian such a great language for literature, poetry, and nowadays for hip hop. Yeah, and the thing is, you can apply the same principles to designing systems. An obvious example is networking, where packets can come out of order, and it's protocol's job to rearrange them back together, or out of order execution in the processors, or even redundancy in QR codes. Yeah, and this is basically what this talk is about. It's about finding those parallels between technology, languages, and stuff like that. And even though I was comparing Russian to English in Russian's favor, I want to say that English has other great properties. First of all, it's a relatively packed and efficient language for communication. And you might have heard that during World War II, American pilots were more effective with radio communication comparing to Japanese pilots, just because English is simpler. I wish I could tell more about Oriental languages like Japanese or Chinese, but I've learned nothing from watching all this anime. But speaking of pilots, I'm pretty sure Russian pilots were efficient too, but in another way, like, you know what I mean. Yeah, and of course English is more widespread, and but we'll get back to this analogy a bit later. So yeah, look for parallels. Excuse me. Another lesson, it's important to stay hydrated. So let's get back to the quote. The limits of my language mean the limits of my world, and try to apply it to programming languages. So technically, any Turing-complete language can be considered limitless. People do interesting stuff with Minecraft, Redstone, with SendMail configs, or with C++ templates, or languages like brainfuck. This is all cute and interesting, but doesn't mean it's useful. But still, in a way, it's every language that is Turing complete is limitless. But different languages provide different paradigms that we use to solve our problems. And what we need to do is just to explore those languages and paradigms to, add new tools to our toolbox, and yeah, to expand our horizons. So let's go take a tour of computer science history. Raise your hand if you know what this thing is. That's great. So yeah, this is a punch card. So machines talk numbers, and each operation is a numeric code followed by an operand or an address. And at the beginning, the programs were written using the punch cards. It was a tedious and error-prone process, but it kind of got the job done. And after some time, assembly was invented, an actual language with symbolic representation of those instructions. So in a way, it was a breakthrough, because assembly freed engineers from memorizing all those numbers, and it made code actually readable. Yeah. So it was one of the first languages to fuse human languages and machine languages. But when assembly was invented, the old school operators who used to punch in the numeric codes, they weren't interested at all. John von Neumann, the guy who invented von Neumann architecture, which is still used in modern computers, was known to get angry at his students who used precious machine time to compile assembly to machine code. He was furious. And surprisingly, the next wave of programming languages was met with the same kind of resistance. I can write a better assembly that your Fortran compiler ever could, they say. So languages like Algol and Fortran introduce a lot of new concepts like type systems, procedures, better control flow loops and stuff like that. They made programming much more humane and more accessible to even more people. As far as I know, Algol has been used for teaching algorithms like for a while during the 20th century, but now it's mostly Python. Anyway. There's one important thing that those languages introduced, apart from actual features, is the concept of portability. They were portable. And this is very important, because if you spoke PDP assembly, you could only talk to PDP computers. But if you spoke Algol, you could talk to any machine in the world. And the same with human languages. If you can only speak Russian, you can only talk to other Russian speakers. But if you speak like English or Spanish, you have much better coverage. The common characteristic of programming languages is their syntax. Syntax is a set of rules that defines the language, this language features and semantics. Syntax can be clever, can be humane, can be expressive or not, but syntax can also be very limiting, because if the language syntax is already finished, you can't extend it. You either have to wait for new standard for this language, or build your own tools that generate this language or something like that. But there was, not yet. So compilers work by translating your source code to machine code, but they don't do it directly. There are a lot of intermediate steps involved, and one of them is generating abstract syntax tree, which is a tree-like structure with the syntactic information removed. So there was one language that decided to skip this step completely. Any idea what is the language I'm going to talk about? Definitely, it's Lisp. So yeah, in Lisp there is no distinction between arithmetic operation, function call, or control statement. Everything is built from primitive atoms that are assembled into the list, and the program is actually one huge list. Most Lisp implementations have a macro system that can be used to build a Lisp implementation just using those macros and a few basic primitives. Yeah. So with language like that, you are no longer restricted by the syntax. You can build your own languages, tailored to your own specific needs and domains. So, apart from its radical syntax, Lisp pioneered a lot of new concepts like garbage collection, higher order functions, dynamic typing, REPL, and stuff like that. Those are very powerful tools and can be used as building blocks for many other language features. If you take JavaScript, for example, nowadays it's kind of a decent language, but not so long ago it was a total disaster. But JavaScript managed to stay useful just because it had first-class functions, and people build a lot of stuff on top of this first-class functions. So yeah, this is a very powerful concept. The Lisp was way ahead of its time. The first versions were created like in 1950s, and it took a while for industry to pick up those features. And since it was way ahead of its time, people even made special machines to run Lisp, like because it was hard to run garbage collection and stuff like that on off-the-shelf hardware. So yeah, even though Lisp syntax is still considered radical by some people, Lisp DNA in one form or another lives in many modern languages, whether it's a modern Lisp implementation like Clojure or a language with a more conservative and traditional syntax like Python or JavaScript. So if there is one book I'm going to recommend today is Structure and Interpretation of Computer Programs, aka SICP. So when I was preparing the talk, I kind of thought about saying you should learn this and that after each part. Like when I talk about assembly, I wanted to say you should learn assembly to understand machine and stuff like that. But the thing is, with this book, you can go through the whole computer science history using just one language and one book, because you will learn to build abstractions, domain-specific languages. You will build your own interpreters, virtual machines, and compilers for those virtual machines. These are just the main abstractions that used in compilers and stuff like that. So you should definitely check out this book. Before we continue. So, we solve problems by explicitly describing each step, but what if we could just describe the problem and let the machine find the solution? I think people ask these questions even before computers, like linear programming can be kind of related to that. There are constraint satisfaction problems and logic programming. And logic programming kind of got a lot of interest during 20th century for people who are building logical system in Lisp or specialized languages like Prolog, where you just have a few simple atoms and you define predicates and rules and stuff like that, and you let the inference engine to kind of do the work for you. And Prolog was used to build those things called expert systems, which were promising to replace real experts in their fields, like people promised to build medical system, chemistry system, stuff like that. The idea was that you will just ask it and it will give you an answer. But the thing is, even though they were simple and understandable, because it's still source code, it's like when we hesitate to commit a binary to the Git, but we are always eager to commit proper source code. So yeah, in a way, expert system was simple in this regard, but they required a lot of manual labor because actual experts had to type in all this stuff, and they couldn't really work alone without computer specialists. Yeah, and you basically had to program each and every rule. So the idea that program writes, the machines find a solution for you didn't really work. The approach I described was part of this thing called symbolic AI, research direction that was primary until late 1980s. Basically, it used logic and language to represent intelligence. And it was, as I mentioned previously, it was cursed by manual labor and limits of logic. I'm not going to go too deep into this stuff, but basically, mathematical logic is an artificial construct and has its own limitations, described like in Russell paradox or Gödel's incompleteness theorem. So yeah, they were burning money like crazy. There was a lot of investment, and the hype was similar to the hype we see today in modern AI or blockchain and stuff like that. And yeah, it ended at some point with a period called AI winter that was characterized by lack of funding, interest, and progress in the field. But there was another school of thought, artificial neural networks. And back in the day, like many things in computer science, artificial neural networks were invented way back in the day. But back then, there wasn't enough computer power to run large networks and to process large amounts of data. And to be honest, there wasn't enough data to process. So the idea was there, but it wasn't kind of useful. It was just some sort of dream. But fast forward to modern times, and artificial neural networks are back in the game. People do awesome stuff with them. Yeah, and it's kind of a breakthrough in a way. We're still far from real AI, but still, this stuff is cool. And as you can see on the picture, those artificial neural networks were inspired by real neurons that fire in your brain. And this is where we go into the nature. Nature can be a source of inspiration for many, many things. Not just like AI. They're even more down to earth stuff. So, for example, Velcro stripes, those things. They were inspired by burdock seeds, or bullet trains. So this is a more complex example. So when Japanese were creating their bullet trains, making them going fast wasn't the biggest issue. The problem was aerodynamics. So like imagine a train going through a tunnel at high speed, and it builds a tremendous amount of air pressure. So when it escapes, it's just destructive and loud, and it's basically not usable. So obviously it can go slower or brake earlier, but what's the point of making high-speed trains, right? So nerds being nerds, one of the elite engineers was a bird watcher. And he was really into birds. And he's noticed that there are a few birds that jump into water hunting. And when they jump, they almost don't make any splash at all. So he thought that there are very nice aerodynamic properties to these birds. So as a result, bird trains. Look how similar they are. So yeah, another picture of trains. Beautiful, isn't it? So yeah, the idea is that nature already spent billion years of evolution like solving those problems, so why not use those solutions, right? And even the idea of evolution itself can be applied to programming by the means of genetic programming, which becomes kind of popular again in combination with neural networks. And here's another example. This is from AutoCAD. So on the left there is a skateboard track, on the right a motorcycle swing arm. So they just specify some kind of constraints and let the machine figure out a proper shape. In the end, those details are lighter than normal details and more robust, and they're basically better. The only problem is that they're expensive to make because you have to 3D print them, and 3D printing titanium is not cheap and easy. But hopefully one day, yeah, and same can be applied to architecture. So this whole thing the whole thing about nature is called biomimicry. There is a whole movement that tries to learn from nature and apply those lessons to engineering problems. You should definitely check out those sites like biomimicry.org, asknature.org. There are a lot of interesting examples. Yeah, and to just get inspired. Let's talk about media. So we went a bit higher into the clouds with neural networks and generated design and stuff like that. But now I want to talk about more down-to-earth things, more applied to practice. So the thing is that code is not always enough. Sometimes you need different media to represent your ideas and to analyze those ideas to solve your problems. So I'm going to give an example from my practice. Let's assume you have a speech recording, right? And you need to remove silence from this recording. And when you record a message, voice message, or just, recording, machine sees this stuff. It's just a bunch of numbers. And if you know how the sound works, they basically, 1 second of recording, there is like about 44,000, depending on sample rate, 44,000 samples. And you can't just manipulate one sample by sample. So you can try to solve this problem in your head, but it will be kind of hard to do because this is how machines see the sound and how you see the sound with your code, right? And hearing it doesn't really help. So first thing you can do is to visualize the wave. Now we already see those points where the silent is. We already can have some sort of insight into the signal, right? And then we just split it into windows and calculate some sort of average for each window. In this case, it's RMS. And then we see, okay, we got those windows. Let's just tune them because they're too big. We play with window size. Now we can just start to skip subsequent windows that are below some specific threshold. And we got our signal with silence removed. This is an example where a different media than we used, like we started with sound and with code and a language, and we used visualizations, a graphical media to help us, to aid us in solving our problems. So, yeah, obviously. Visualizations help solve your problems, so you should definitely use them. And for some, it might sound obvious, but like if you're a backend developer, sometimes it's kind of hard to get your head around it. So I definitely recommend to start using it, because like in scientific communities, people has been using visualizations for a while, and not just for finding insights in their data, but also for sharing the ideas and communicating those ideas to other people. And many industries use sophisticated software which provides visual tools to work with your data to achieve the stuff you will not be able to achieve just by code. But if you take a look at the lower right corner, this is how web development looks. Yeah, this is weird. There have been many attempts to kind of solve this, but of no avail. But hopefully one day. I actually stole those two slides. I mean, this whole picture from Webflow, an app that tries to solve this problem. So maybe maybe Webflow or Framer will be able to fix that. So yeah, language is an important trait of human species, but we can also see, hear, taste, smell, touch, perceive temperature and pain, balance, feel time, and so much more. So let's get beyond the language. That's all, folks. Thank you. You can feel free to ask any questions. We have plenty of time because I finished fast. If you don't feel comfortable asking a question in English, feel free to ask in Russian. We will translate that as well, but try English as well.
Okay, any questions?
No questions. Thankfully.
Yeah, actually, not really a question, more like,
maybe I wasn't giving too much attention while tweeting about your talk, so I was gonna ask you to give me like a short summary, maybe 1-2 sentences, like what was your talk about?
That was my biggest fear, to be honest, that people will not understand. But the thing is that there is no single thing, and you're kind of supposed to read between lines. But the whole idea is that we can't just use single tool for everything. We just need to reach to other tools, to other languages, to other media. We should reach to nature and stuff like that. And yeah, I was just trying to give you examples to inspire you. Does that answer your question?
Yeah, thanks.
Stepan, thank you for your talk. Your talk was about drawing inspiration from languages, from nature, and from people. I've heard about languages and nature. What about people?
That's a good question. I kind of forgot about that. So I'm just going to give an example that I've heard from another talk. So there was a guy who was talking about data sourcing. So you know what data sourcing is? It's like not like a traditional database where you can just read and write fields. It's just one large journal of transactions of data. You never remove something from a log, right? And he gave a very interesting example about one profession that's been using data sourcing like forever, and it was accountants. So a ledger in accounting is basically a data like a huge log. You just don't remove fields from your ledger. You just add debit or credit, and this is a good parallel between technology and professions and people you can be inspired from. But obviously, if we're talking about different media, go ahead and reach to people who work in these different media, to designers, to sound engineers, to other kind of engineers, to biologists, to whoever to bird watchers, I don't know. So yeah.
Thank you.
Thank you.
Any other questions?
Yeah, so thank you for your talk. I wanted to, I mean, you said about Lisp, and the idea came to my mind. Well, there are two questions. First one is whether there is a language to write languages. I mean, there is that thing that you call Quine when you run a program and it generates another program, and I guess it's easier. I mean, you can do that in Lisp because in Lisp data structures are language and language is data structure, but still, are there any good examples? And the related question is, I've heard that there is, I mean, you've said about generating front-end, generating layouts and HTML markup and stuff from images, but I've thought about, I remember I heard that it is possible to generate programs, I mean, to eliminate programmers and to generate programs by writing some cool AI or stuff. And I wonder, what do you know about that? Because I've heard just that fact, and that was all.
Thank you. So, I guess it's kind of complex because you don't always have to create some very intelligent system to to generate the right something for you. It doesn't always have to be some sort of AI. And I guess in a way, your second question answered that yeah, you can just use existing tools, or I mean different tools like editors or stuff like that to generate your programs. But I don't know, there were attempts that, I mean, if you take, that was a good question because you kind of got me here. I don't know. I can't give you an easy answer, but there were many attempts to solve this problem from different angles, and I guess it all depends on a specific problem. You can start from something simple like just generating stuff, because it's ridiculous that these days we manually write APIs, and we can, like, for example, design APIs that actually automatically talk to each other and like discover each other, and we don't have to write bindings. And you go as high as possible, like just specifying constraints for some hard task and letting the machine figure it out for you. Just different aspects, different to different tasks, I guess. Another unanswered question.
Any further questions? I wasn't expecting you so fluent. You're freaking people out. Look at them, they're regretting
Sorry
coming
about
here.
that. I'm really trying to speak slower, but I mean, yeah, sorry about that.
No, I guess that's okay. Any other questions?
Thank you for your talk. It's maybe kind of philosophical question. Once I got an idea that science on its own is just process of science, is kind of reverse engineering nature around us. So we don't have its rules, orders, but we try, we sit, we observe, then just put it all together and use it in our technology. So what do you think about it? So basically, do you feel science the same, or maybe I'm wrong here?
So you mean, are there some specific rules we can use to analyze, or what is the question?
What you talked about getting inspiration from the world around us. So basically, if we look through history of science, all the science is nature we understood and tied to our needs to implement something we want. So we figure out all these rules and just plan and implement them. So basically, that's the only way of science.
Yeah, that's definitely true.
Okay, so that's what I just wanted to say this.
No, I guess in a way there's still a lot of stuff that is left unanswered, but the thing is we're not like, we are people in the industry, we're more engineers than scientists, and we're not always follow the scientific method, I guess. There's just a lot of copy-pasting that goes into the industry, and we don't always like dig deeper, and we don't always try to see those parallels. And yeah, maybe it wasn't like that before, but nowadays, yeah, it's just we're not always using the scientific method, to be honest. And yeah, that will be nice. And yeah, I guess I wanted that answers your question.
Yeah, thank you.
Thank you for your question.
So there is a saying, like, the programmer that learns to code in C will always write program in C in any language that he can put his hand on. Like, I personally saw this in action, and it can be kind of freaky, but it works exactly like that. Do you have like some tips and tricks how to break out of this, duckling syndrome from this, like the mold that you got very, very early on?
I don't know, like I guess if you can't find your habits programming in C, you can just program and go.
Well.
But yeah, that's a good question, because personally I've met people who just couldn't switch. They were just whatever they touched, they were writing C. I guess it's you just have to start early. I mean, yeah, because I guess the modern generation, they're not always like that, because like imagine growing up imagine learning to code in 90s or 80s. There wasn't that much choice, and you probably was just using a single language or two, and that's it. But these days there are so many languages, and people actually have trouble like learning them all. So I think for the current generation, it won't be such a big problem, because yeah, there's just so many languages and so many paradigms, and you can kind of resist from learning them. Another interesting example that some paradigms from way before they getting popular in some ways. If you take functional programming and like purely functional data structures, they're getting popular in user interface development. If you take React, Redux, all this stuff, this is where mainstream use case, basically creating a web application, introduces a lot of concepts that previously were only used for, in academic circles. So yeah, I guess. Yeah.
So basically, kill all the programmers that learned to code in the 80s. All right, thanks.
No, I mean, yeah, there is some sort of correlation, but of course not. There are a lot of awesome people who are able to change their mind.
Don't forget CS50, like, for example, in Harvard, C is taught first. So does it mean everybody who watches that, who studies at Harvard, is inflicted by this incurable disease and they cannot switch their minds? Okay, I'm sorry.
Or was it?
Thank you, Stepan.
Thank you.